Imagine looking out over the water and seeing a delivery boat violently convulsing. It's sputtering, coughing, and spewing thick, greasy smoke into the air like a burnt jellyfish. When a breakdown like this happens, most vehicle owners go into a state of pure money-driven panic. You hear that horrible metallic screech, and imagine your hard-earned cash escaping your pockets to pay an exorbitant mechanics bill. That deep panic stems from a specific psychological barrier. When we look under the hood at a metal engine block, we see a terrifying, incomprehensible black box. We assume it's entirely beyond our understanding. Because we treat the machinery like magic, the moment the magic stops working, we assume we're doomed. But you don't need to hire a mechanic to understand what makes a vehicle run. You really just need the mindset of a fast food fry cook. An engine and a restaurant grill perform the exact same job. They both take raw ingredients, apply heat and pressure, and output power. One produces the flavor that satisfies a customer, the other produces the kinetic motion that delivers the food. Once you strip away the heavy metal, fixing a sputtering engine simply requires learning a 4-step cooking recipe. This animated diagram shows the basic kitchen anatomy of our engine. The outer walls form a room called the cylinder, and inside is a piece of metal called a piston moving up and down. Think of the cylinder as the kitchen itself, and the piston as our fry cook working the spatula. Step 1 is getting the groceries, known as the intake stroke. As the piston drops down, it opens up space and sucks in a mixture of air and fuel. It's exactly like pulling fresh buns from the pantry and grabbing a juicy patty. Step 2 is the sizzle. This is the compression stroke. The piston moves back up and squishes that air and fuel mixture into a microscopic space. You can't just toss ingredients lightly on a grill. You have to press them down firmly to sear in the potential energy. To make sure none of that high-pressure sizzle escapes, the piston relies on piston rings, small metal bands that seal the gap between the piston and the cylinder wall. They act exactly like the firm edges of a spatula pressing down securely. If the rings fail and let pressure leak, the sizzle is lost. Without extreme sealed pressure, raw ingredients cannot be transformed into explosive kinetic energy. Now for step 3. The flip. At the moment of maximum pressure, a tiny component called the spark plug fires a bolt of electricity. This ignites the tightly packed fuel, creating a contained, high-pressure explosion. The sheer physical force of that blast slams the piston down. This is the power stroke, and it is the actual source of motion that drives the entire vehicle forward. Finally, we serve the order in step 4. The piston comes up one last time during the exhaust stroke, pushing all the burnt, leftover smoke out of a newly opened door to clear the griddle for the next batch. This animated diagram illustrates how a real vehicle multiplies that power. Most engines use 4 cylinders firing in an alternating sequence. While one is pulling in ingredients, another is sparking. It's a beautifully choreographed kitchen ballet. A smooth, reliable ride is the result of this continuous, perfectly timed sequence of intake, compression, power, and exhaust. So if we know the recipe, what happens when a vehicle violently sputters and shakes like our delivery boat? We look for the missing ingredient. This diagram displays a classic clogged ketchup bottle scenario. In an engine, this is a dirty fuel filter. When the filter screen gets clogged up with heavy gunk, it restricts the liquid. Only a tiny trickle of fuel gets through, starving the engine of its core ingredient and turning that mighty explosion into a weak sputter. But the boat is also pouring smoke and radiating heat, which brings us to the second symptom. The engine is running a severe fever. An engine generates immense heat from hundreds of explosions a minute, so it uses a cooling system. Think of it as a personal ocean breeze. If the liquid coolant leaks out or runs low, the engine loses its ability to wash that dangerous heat away. Unmanaged heat is fatal. Left unchecked, the rising temperatures will warp the internal metal parts, completely melting the seals and ruining the griddle beyond repair. To perform immediate mechanical triage on the sputtering, you can try firmly tapping the dirty fuel filter with a spatula handle. This knocks loose just enough gunk to let the fuel flow and get you home. For the fever, the fix is patience. You cut the power, let the metal rest and cool down, and then top off the thirsty coolant reservoir with emergency water to restore the ocean breeze system. You turn the key, and instead of a violent death rattle, the engine catches. The shaking stops, replaced by a low, steady, smooth hum. By treating the engine like a simple kitchen with a specific set of needs, you avoid the tow truck. Understanding a machine's symptoms through a simple framework leads directly to actionable, money-saving solutions. This four-step logic applies to almost any complex system that converts energy. In the ocean, a jellyfish is essentially a floating grill turning plankton into a sting, and even a starfish can be seen as a machine that turns donuts into more starfish. When you encounter an intimidating problem, you don't have to panic. You just have to break the system down into its basic steps. Look for the missing ingredient. Look for the lost pressure. Look for the excessive heat. The world feels less scary when you realize it's just a collection of little engines, all with their own ingredients and their own sizzle. You can master anything if you're brave enough to look under the hood. If you enjoyed this breakdown, make sure you hit that like button and subscribe for more unexpected insights into how the world works.